The idea between adding and subtracting rational expressions is very similar to adding and subtracting fractions. The thing that we need is common denominators. Okay, we need common denominators here. Now, when it comes to having common denominators, it's a little bit different because now you're dealing with expressions, you're dealing with factors, you're dealing with variables, you're dealing with powers, right? So it's not as simple as just like, okay, what is the lowest common denominator between 3 and 2? Okay, even though that is a component of it. Okay, so the first thing you want to look at is, okay, let me focus right here on these two factors, 3 and 2. Okay, first of all, they're not the same, right? The denominators are definitely not the same, okay? But our job is to get them to be the same. If we want them to be the same, we're going to have to multiply one denominator by certain factors and multiply the other denominator by other factors to get them to match, right? So if I was looking at 3 and 2, first of all, they're not the same value, but I can get them to be the same one, right? So I'm looking for a lowest common denominator here between 3 and 2, and that tells me that that's going to be 6, right? So what I need to do to the fraction on the left side is I'm going to need to multiply the denominator down here by 2, okay? And on the right side, I'm going to need to multiply this denominator by 3, okay? Now, the reason why I left some space inside those parentheses is because there's other things we're going to need to multiply by to get them to match, right? Currently, the denominator on the left, right, 3m squared, well, that has m to the second power. The one on the right has m to the third power. So if I want those to match, right, this one, if the right one has m to the third, I want the other one to be m to the third as well. So I'm going to also need to multiply this one on the left by m, right? So when I multiply, I could get 6m to the third, 6m to the third. Okay, now the denominator on the left also has n. The one on the right does not. So we're going to have to multiply the one on the right by n. Sorry, I almost used red. We want to multiply by n there so that it does match, okay? So if you see here, like if I were to distribute this this 2m, I'm going to get 6m to the third n, and then the same thing on the right. If I multiply this 3 times 2, that's 6m to the third n, okay? So that's going to give me the same denominator on both fractions, okay? However, if I do multiply the bottom by 2m, I also have to multiply the top by 2m. If I multiply the top of the second fraction by 3n, right, same product has to go to the denominator and the numerator. Okay, so now let's see what we get here. In my numerator, this is where you want to do some of that distribution. The 2m times 3, that's going to give you 6m minus. Okay, now I'm looking at the other side of the fraction. This is going to give me 3 times 3, so that's 9n. Okay, all over. Here, my denominator should be the same, right? It should be the same, right? So now this is going to be, that's a 6m to the third n. And then this denominator, sorry, I forgot to put the space here. When I multiply 3 times 2, that's 6m to the third. And then I have my n, right? So now they have the same denominator. Do you guys see that? Okay, so because they do have the same denominator, I could just combine the denominators and leave this expression as 6m minus 9n all over 6m to the third n. Okay. The last thing here is to look for, is there something in the numerator that I can factor out from both of those terms so that then I can simplify at the very end? Very similar to what we did in the first two lessons. Okay. So now I can see that between 6 and 9, I can factor out a 3. That's going to leave us with 2m minus 3n all over 6m to the third n. Okay, so now the only thing here left to do is I can reduce that 3 on the outside, right, that factor, and the 6. So if I reduce it, that gives me a 1. If I divide this by 3, that gives me a 2. Sorry. So now that leaves us with 2m minus 3n all over 2m to the third n. And that would be your expression right there. Any questions on that so far? Okay, so let's just restate the goals here for this types of problem. When you have two fractions, the denominators need to be the same. Otherwise, you cannot combine anything in the numerator. So your first job is to find out what can I multiply to each denominator so that I can get them to match. Typically, you're looking for what does this denominator have that the other one doesn't, okay? And it's kind of like flip-flop, all right? So we needed to get the numbers to both equal a common number, which was 6. So we had to multiply the left side by 2, the right side by 3. Since the denominator on the right side had m to the third, and the one on the left only had m squared, we had to multiply by an additional m on the left side. So that when we did multiply, m times m squared would give us m to the third. Okay. Since the denominator on the left had an n, and the one on the right did not, then we had to multiply by n on the right side. Okay, and then we ended up with exactly the same denominators. Once those denominators are the same, you can condense the denominator because you only need, as long as it's common, you can just bring it down as 1, and then the numerators combine on the top. Okay, so now you just left with 6m minus 9n, and then you try to factor it so that you can try to simplify as you go, okay? Once you have something that you can simplify, you factor, you can go ahead and divide it out, or cancel it out, and then you bring down your final expression, okay? Any questions so far? Okay, all right, looks good, looks good. Okay, let's move on to the next term. Okay, so again, clearly denominators are not the same here. Here you have factors, however. Watch this, right? You have 2 times 3n plus 1, and you have 2n. Okay, what you don't want to do in the denominator is start to distribute factors, because then it makes it harder to find out what you need to multiply by to get it to be common, right? Imagine that you distribute the 2 times the 3, you get 6n, and then you multiply 2 times 1, you get plus 2. It's going to become very difficult for you to find out what do I need to multiply to the left side to make it match the right side. Okay, so if it's already factored, leave it factored. Okay, what you want to do is now find out what do I need to multiply to the left side to get it to match the one that's on the right side, and vice versa. Okay, so look, I noticed that they already both have 2's, right? So I don't need an LCD, lowest common denominator. That's okay, we're going to leave that 2 there. What does the one on the left need that the right one has? What factor? So you want to think of this as an entire factor, this as an entire piece. Okay, does the one on the left have a 3n plus 1? Yeah, so you want to think of this as 2 times n is not the same as 2 times 3n. That's a little bit different, okay? So what I want you to see this as is 3 separate pieces. 2 is a piece, n is a piece by itself, and 3n plus 1 is a piece by itself. Right? These are all separate factors. Okay? So because the one on the left does not have 3n plus 1, we have to multiply by a 3n plus 1 on the left side. Okay? So we're going to multiply that to the left, and we're also going to multiply that to the right. I mean, to the left, on the top and the bottom, sorry. On the right side, right? Since it already has a 2 and a 3n plus 1, what else does it need additionally? What factor does the left denominator have that the right one does not? Do you need to include the n from 3 plus 1? No, you want to think of that. Yes, okay, so because 2n already has the variable n, right, but that's not the same n that belongs to 3n. Okay, so the 3n, that you cannot, you can't think of the 3n as this here. Okay, that those ends are separate, right? Look at what I have in the expression here to the left. Right, I have a 3n plus 1, right? There's an n there, and then there's also another n outside, right? So think of the factors as 3n plus 1 times 2 and then times another n. Okay, so what's needed on the right side? I'm sorry, what's needed on the right side? Yeah, you multiply n to the right side now. Okay, so you multiply it by n only. Okay, and then an n to the top as well. Okay, so now in my denominators, right? In my denominators, both of my denominators should read the same right now. And I'm not going to distribute anything. I'm just going to leave them as factors side by side by side. Okay, so I have a 2 times an n times a 3n plus 1. Okay, on the right side, I have a 2 times an n times a 3n plus 1. Okay, so just because you see the letter once, this is extremely tricky. I know it takes some time getting used to, and it's hard to explain like over the Zoom. Okay, this is a lesson that usually in person goes a little bit better. Okay, but the 3n plus 1 is a separate factor, completely separate from the n that's not inside of the 3n plus 1. Okay, so you're basically looking at two different n's. Okay, you want to make sure that your denominator has two separate n's. All right. So now that those denominators are the same, okay, now I can focus a little bit more on the numerator, okay? So in my numerator, I had 3n plus 1 times n minus 1. And then on the other side, it was just 2n times n. Okay, let's do the easy one first. Here we had 2n times n. That's just going to give us a 2n squared. Okay, there was a subtraction sign here. And then on the right side, I'm sorry, the left side, let's go ahead and just FOIL this out. So I have 3n times n. That's going to give us 3n squared. 3n minus 1, so that's minus 3n. 1 times n, that's a positive n. And then 1 times negative 1 would be negative 1. Okay, so let me just clean this up a little bit here. We have 3n squared. Negative 3n plus n would be negative 2n minus 1 all over 2n 3n plus 1 minus 2n squared all over 2n 3n plus 1. Okay, the reason why I don't want to distribute the denominator right now is because if I do, then when I want to simplify, then I'd have to factor it back out again. Okay, so I don't want to do that. I'm just going to leave it that way because then it's much easier to cancel or divide things out. So now in the numerator, right, because the denominators are the same, I can just go ahead and combine everything in that numerator. So it's 3n squared minus 2n plus 1 minus 2n squared all over. Here's my common denominator of 2n, 3n plus 1. Okay. All right, so now I have common terms that I can clean up in the numerator, right? 3n squared minus 2n, that's going to give us a 1n squared minus 2n plus 1 all over 2n, 3n plus 1. Okay. All right, so I've ran out of space a little bit, but moving up here, okay, I noticed that my numerator is a trinomial, and if I have a trinomial, I have to try to factor it, okay? So I'm looking for factors that can multiply to be 1, but add up to be negative 2. Most likely, those factors are going to be n minus 1 times n minus 1. Okay, my denominator would be 2n times 3n plus 1, okay? However, there's nothing there that is in common in the numerator and the denominator, right? N plus 1 doesn't show up anywhere in the denominator, so I can't I can't cancel those out. So even though I factored it into the most simplified form, there's nothing to cancel, so I can just go ahead and box it now. Isn't the 1 negative? Did I mess up somewhere? Which one? Which one do you mean? Oh, you're right, you're right. Oh, yes, I miswrote it, sorry. Okay, that changes things a little bit. Okay, that means that this right here is also going to be a negative 1, which means that then that numerator, I don't believe is factorable anymore. Yes, you're right. Thank you. Thanks for catching that. Okay. So there it is. That should be your final expression there, because n squared, and this is n squared, minus 2n minus 1, there's no factors that multiply to be -1 and add up to be -2. Okay. Any questions on that one so far? This one is a little tricky because I know that I know you see the 2 times the 3n and you kind of see the n there, but it's not quite the same as having the n on the outside of that factor, right? So if you see a factor that has 3n plus 1 and then you see another factor that says 2n, you need to make sure that there is an n outside as well, okay? So both denominators would need an n that's outside of the factor of 3n plus 1. Okay, and so that's why I highlighted them different colors, okay, showing you that those are the 3 different factors. Those are the ones that each denominator needs. Okay, any questions there? Please feel free to let me know if something doesn't quite make sense. Are we okay so far? Okay. How did you get both denominators to be the same? Okay, well, I looked at each denominator from at the beginning, the original one, and I looked to see what was it that they did not have that the other denominator did have. Okay, so starting with the 2, right? Each 2 I highlighted in yellow. Because they both have 2, then that's already good. They're okay. Nothing needs to be changed there in terms of the coefficient. Okay. Now the denominator on the left has 1n. The denominator on the right has 3n plus 1. Okay, so if I need the denominators to be the same, I then have to multiply the one on the left with whatever is missing, right? What does it not have that the one on the right does? Well, if it's 2n, 2n is missing the 3n plus 1, right? So I had to multiply the left side by 3n plus 1 because that's what was missing in order for it to look like the one on the right, okay? The one on the right has 2, it has 3n plus 1, but it doesn't have a single n, right? An n that is kind of by itself. So then I had to multiply the one on the right by that n, top and bottom. Okay, then you notice that once I did that, they each have the factors, they each have 2, they each have an n that is on the outside, and then they also each have 3n plus 1, right? So they have all 3 of those factors. That's what makes the denominators the same now, right? So they have the same denominator of 2n times 3n plus 1. Okay, once you have that, you can move forward in the problem. Does that make sense, Jose? Okay, yeah, it's a little bit of like an art form, like trying to figure out what does this one need that the other one doesn't, or what does this one have that the other one doesn't, so what does it need? Okay, so it's kind of like back and forth, right? Okay. All right, so let's take a look at the next one. Okay, the next one, this you can see, right? Like your eyes kind of trick you because initially you might think, okay, they both have n. One of them has -2, the other one has +4, right? So then I just need to add something to the left side. But you can't add things to the denominators, right? So you need to multiply. The only thing you can do to make denominators the same is multiply them by certain factors. So then if I were to wrap this in parentheses, I think it'd be a good move for you to do as well. Now you're looking at this as a factor, n minus 2, and the other one is as a factor of n plus 4, okay? Here, they're both missing something to make them look like they are common, right? And again, it goes back to what does the left one need and what does the right one need so that they can both be the same. A lot of times, it's really just about multiplying it by the opposite factor, okay? So in this case, if I want the denominators to be the same, I can't change anything inside of those parentheses. There's nothing I can do to change that, but I can multiply by something. In this case, I'm going to multiply by what it needs. It needs an n plus 4. okay? So n plus 4 is what it needs, right? On the right side, what does that need? So that the denominators can be the same. Yeah, you need an n minus 2. Yeah, right? You need that factor of n minus 2. And then if you do it to the left, I mean to the bottom, you do it to the top as well. Okay. All right, so now we can go ahead and bring that denominator down as factors, okay? You don't want to FOIL because then it's going to create a mess and then you're going to have to probably factor it back. So leave it as two separate factors. In your numerator, you can distribute there. So you have n times 4n, that's going to give you 4n squared. And then you have 4 times 4n, that's going to give you positive 16n, okay? You have a minus sign here. In your numerator, what you have is a 4n minus 8 all over your factors of n plus 4 and n minus 2, okay? Now, the denominator on the left, you have to be, I'm sorry, the one on the right, the fraction on the right, I'm going to put this in parentheses. The reason why is because I have a negative out front, okay? So when you start to combine the numerators, you got to treat that negative as something that needs to be distributed into both of those factors or both of those terms. Okay, so what I mean is this. Okay, now that you know that those denominators are the same, you can go ahead and combine them as n plus 4 and n minus 2. And you're going to start to combine everything in the numerator so you can collect like terms. So you can go ahead and bring down the 4n squared plus the 16n, but then this negative will need to be distributed to both of those terms following it, okay? So that's why it's smart to put parentheses in the second numerator, because sometimes that negative will need to be distributed. The most common error is to not put parentheses, and then guess what? You're going to end up writing it as minus 4n minus 8. Okay, so you're going to have one of those factors, it's going to have the wrong sign. Okay, so when you do distribute that negative correctly, you're going to get minus 4n, and then that's going to be plus 32. I'm sorry, what? No, plus 8. Plus 8, sorry. Okay, so there we are. Okay, you guys with me so far? Yeah, the negative sign is a little bit tricky, right? It's a subtraction, but whenever you have multiple terms behind it, you need to make sure that that negative gets distributed, okay? You don't want to just copy that second numerator straight down, because if it was a plus sign, you could just copy straight down, right? Because the plus sign isn't going to change anything. But when it's a subtraction, you are subtracting the second expression. So you're going to have to distribute that negative to get the correct one, okay? Like, why did I not, like, for example, why did I not use it? Why did I not use it in this problem? Because there was only one term there, right? So minus 2n squared, it's still minus 2n squared, right? I don't have to worry about, am I going to get the wrong sign on one of them, because it was just one monomial. But whenever I have multiple terms like I did here, right? I have one, then I have two. I need to make sure that that negative is correctly applied to both. So that's the biggest issue. Okay, so now from there, let's go ahead and clean up the numerator. 4n squared plus 16 minus 4n. So we can go ahead and say, okay, well, we got 4n squared. 16 minus 4 would be positive 12n. And then plus 8 all over n plus 4 and n minus 2. Okay. All right. So again, numerator, look to see if we can factor this. It looks like each one has a common factor, a GCF of 4. So if we factor out of 4, we can say that's n squared plus 3n plus 2 all over n plus 4 and minus 2. Trying to factor it down as far as possible to see if anything can be divided out. So looking at this trinomial now, the n squared plus 3n plus 2, factors of multiply to be 2 but add up to be 3, we're looking at n plus 1 times n plus 2, right? With a 4 out front, and then my denominator of n plus 4 and n minus 2, okay? Can anything there be divided out? No, right? Nothing matches, okay? Even if we try to divide out a negative, it still wouldn't match, okay? So in this case, although we were able to factor it and simplify it all the way far as possible, nothing can be divided out. So that's as simple as we can get our expression. Okay, any questions there? If you divided a negative from the numerator, is it because you're trying to get these like the n minus 2 to match? Here's what would happen if you did factor out a negative from that expression. If you factored out a negative, you would end up with negative n minus 2. So even if you did factor out a negative, the fact that you have negative n minus 2 and n minus 2, those are not like terms anyway. So you can't factor it out. I mean, you could, but you can't cancel out. You can't cancel them out anyway. So there's no point in factoring out the negative. It's not going to be useful in this particular case. Okay. All right, no problem. All right, let's move on to the next one. Okay, so walk me through this one, right? Tell me what you guys think here. Again, ignore the numerators for now. You're only focusing on the denominators. What do you think you need to multiply to the denominator on the right? I'm sorry, on the left side. What are you going to need to multiply? What does this denominator need that the other denominator has? Yeah, we need an r plus 3, right? You're getting the hang of it now, right? So if you multiply by r plus 3 on the right, do it to the top and bottom. I'm sorry, on the left side, top and bottom. What does the rational expression on the right side need that the other denominator does have? Yeah, this time it needs a 2, right? You need a 2. Okay, so now, right, in your denominators, you should be able to just get 2 times r plus 3, 2 times r plus 3, right? In your numerators, now you can go ahead and start doing some distribution, start trying to clean up. Okay, so here you're going to want to multiply r times 2r, that's going to give you 2r squared. 3 times 2r, that's going to be a positive 6r. Okay, here the 2 that multiplies to give you 2r. 2 times 2 multiplies to give you 4. Okay, now you see how my numerator here is behind that subtraction. So you want to wrap this in parentheses because that means that you're going to have to distribute that negative. Okay, so give me a sec. All right, thanks. Okay, so here what you want to do is then distribute your negative, okay, after you've combined your denominator. So you know your denominator now is going to be 2 times r plus 3. You can start bringing down 2r squared plus 6r, but then you want to distribute this negative here. So that's minus 2r minus 8. Okay. All right, so now 2r squared minus, I'm sorry, that's going to be 6r minus 2r, so that's plus 4r. and then minus 8 all over 2 times r plus 3. Okay, so let's see how far down we can simplify this. We can see here, where did 8 come from? Oh, okay, I keep making that mistake. Sorry. Second time today. Okay, that's minus 4. Sorry, this is minus 4. Yes, you're right. Thanks for pointing that out. Okay, does the work look good now? I'm off my game today. Okay, yeah, I think it looks good. Okay, so now numerator, we can factor out a 2. That's our GCF. We're left with r squared plus 2r minus 2 all over 2 times r plus 3. Okay, let me write that a little bit clearer. Okay, so from here, numerator, do you guys see any factors that might be possible for that? Multiply to be -2, but add up to be 2? I don't think there are, because 2 times 1 is, yeah, I don't think that's going to work. Okay, so then in this case, the only thing that can divide out is the 2 over 2. Okay, and then that's going to leave you with a simplified expression, or a simplest form of r squared plus 2r minus 2 all over r plus 3. Okay, and since we couldn't factor out that numerator, that's okay. You just leave it that way. And there you go. And give me a second. My battery is on low, so I need to go grab my charger really quickly. Just give me 1 minute. Is it working? Okay. All right. Technical problems. Okay. I feel like this happens in class all the time too. Like I'm in the middle of I'm in the middle of it and then I have to go run and grab the charger. Okay. All right, I'm back. So now let's think about this last one, right? I think you kind of have the hang of it. What do you think needs to be multiplied to the denominator on the left so that it has the same factors as the one on the right? Yeah, this time we need both, right? Because they both share this 2, right? But the denominator on the left only has 2. So it's going to need both the r plus 1 and the r minus 3. Okay, so let's go ahead and do that. Okay, let's do it to both sides. Not both sides. I keep saying both sides. I mean top and bottom. Okay, so now denominators, those are going to match. We have a 2 times r plus 1 times an r minus 3. Okay, you're going to be tempted to want to FOIL that out. Remember not to FOIL it. You want to keep the denominator in a factored format. Okay, factor times factor times factor. In the numerator, are we going to multiply by grouping the numerator? In the numerator, first what I'm going to try here is I'm going to try to distribute and there's many ways to do it as long as you multiply one factor times the other, okay? So I think the best way to do this here might be to first multiply 4r times, you only need to multiply the 4r times one of the factors. You don't multiply the 4r to both. Okay, so let me go ahead and off to the side, I'm going to do this work. Okay, so we had, let me write it like if it was in a separate order, I'm going to write it as a 4r times r plus 1 and then r minus 3. First, I'm going to focus on foiling or multiplying the 4r to the first term. So I'm just going to multiply 4r times r plus 1. 4r times r is 4r squared, and then 4r times 1 will be positive 4r. Okay, so after I did that product, now I have this, which I then need to multiply to r minus 3. Do you see that? So you don't need to multiply 4r to both. You don't need to FOIL it to or distribute it to both of the other factors. You only multiply to the first factor, and then whatever you get, you multiply to the second factor. Okay, does that make sense? So I guess that's what you meant, right? Multiply by grouping. I guess if you want to group them, I guess you multiply the first with the second. Whatever you get, you multiply to the third. Okay, so that way you kind of keep it in order. Okay, so now 4r squared times r, that's going to give you 4r to the third. Yeah, now you can FOIL this. Then you multiply 4 times negative 3, which will give you negative 12r squared. Another 4r times r, that's going to be 4r squared. And then 4r times negative 3 would be negative 12r. Okay, so if I condense this, I can simplify these two together right here. So that's going to give us 4r to the third minus 8r squared minus 12r. Okay, so that's my numerator for my left side. Okay, so I can bring down 4r to the third minus 8r squared minus 12r. Okay, and then you can bring down the rest plus your 2r numerator here. And your denominator here, nothing needs to change because by multiplying r plus 1 and r minus 3 to the left side, it matches the right side, right? So they look the same. There's no need to multiply the right side by anything. You just bring it down as 2 times r plus 1 times r minus 3. Okay. All right. So now at this point, what you can do is just condense and clean up everything in the numerator. Okay, so go ahead, bring the denominator down first since nothing is going to change there. You just copy it down. But let's see, I can probably combine the negative 12r plus a 2r, right? Those I can combine, those are like terms. So in my numerator, we'll get 4r to the third minus 8r squared. Negative 12r plus 2r would be a negative 10r. Okay, so now numerator, you can see there that there is something that they have in common. You can factor out a 2 and they all have r, right? So you can factor out r as well. Let's see what's left. So we factored out 2, that's going to leave us with 2r squared minus 4r minus 5. Okay, all over 2 times r plus 1 times r minus 3. Okay, all right, we're not sure if that trinomial is going to be able to factor into anything else, so maybe let's try some Xbox here and see if we can get something out of that. Okay, so we want to see Can I factor that trinomial any further? Possibly. I can then divide out one of those terms in the denominator. So when we multiply across here, our a with our c, that gives us negative 10r squared, but it has to add up to be negative 4r. Okay, do we have any options that might make that work? Yeah, I don't think so. No, there isn't, right? Because in order to get 10, you need like 5 times 2 or 10 times 1. And even any combinations of those, it doesn't add up to be negative 4. Okay, so it looks like we have a prime factor or a prime trinomial there. Okay, so we're not going to be able to factor this any further, which means that then the only factor here that we can divide would be our 2 with this 2. So finally here we can say this is r times 2r squared minus 4r minus 5 all over r plus 1 and r minus 3. Okay, and that is it.